In this lesson, we're going to be talking about parallel lines and transversals and how they interact with each other. We're going to start off, first of all, by just defining some words and some concepts that you guys are already familiar with, probably, and that is parallel lines and parallel planes. Parallel lines are coplanar lines that go on infinitely in either direction, and they never cross or never get closer to each other. Parallel planes are along have the same concept that planes. Remember, planes go on forever in all directions. So parallel planes go forever in all directions, but they never cross each other. Some real world examples of parallel planes are like the floor and the ceiling in your house. All throughout the house, in most cases, the floor and the ceiling do not meet unless they happen to be up in the upstairs in the attic or someplace like that where the roof slopes down. But on the first floor of your house, your floor and your ceiling are probably never going to meet each other. The concept that you may not be all that familiar with is the term of skewed lines. Okay, the skewed lines are lines that don't intersect, but they're also not coplanar. Right? So parallel lines are coplanar. It means they're on the same plane. Skewed lines are lines that are on different planes, and that obviously do not intersect. So a real world example of that would be the lines. If you have a suspension ceiling in your basement, that in the ceiling in your basement, that you have the metal pieces that your ceiling panels lie in, and then the stripes in a rug or a carpet that you have on the floor. Your ceiling panels and your stripes on your carpeting are never ever going to cross. So take a minute and pause the video and copy these definitions into your notes. You can draw the pictures if you want to, but as long as you understand and have the actual word definition words written down, that should probably be sufficient. All right, so some examples that we're going to look at. We're going to talk about what segments are parallel to segment BC. Well, if we look at that, BC is this edge on this cube. Okay, BC is that edge right there. So we're looking for other edges that are parallel to that. Well, we have three of them. We have DA, we have EH, and we have FG. All right, all the other edges in this cube are going to be either intersecting or skewed to the line segment BC. The next problem we're going to be looking at is, what is a segment that is skew to EH? Well, EH is this back left corner, right back here. EH is this this line here. So skewed, remember, skewed means that they're not coplanar. Okay, so they're not going to be on this back side or on the left side. Also not going to be on the bottom or on the top. Okay, so really there's only one plane, which would be this plane over in the right hand plane here. All right, that plane there is going to be the only well, no, actually it's not the only one, because you have the front as well. You have the front plane as well, the DCBA. All right, so what is the segment that's skewed to EH? Well, so remember, it cannot be parallel. It cannot be parallel, because if it's parallel, you can draw a plane through it, right? So that takes care of CB, takes care of FG, takes care of DA. All right, so it cannot be parallel, and it cannot intersect, which takes care of EF, HG, and DE, and HA. All right, so that leaves us with this line right here, which is FC. Okay. Also this line down here, GB or BG, and then the bottom here, AB, and DC up here on top. Okay, so notice that my strategy for identifying the skewed lines was to eliminate all the lines that were either parallel with EH or that were intersecting EH. So we want to look at what are all the segments that intersect EF. Well, EF is this up here. All right. Let me try red again. Blue doesn't show up very well. EF. All right. So we want to talk about everything all the lines that intersect that. So, well, right here, if we look at point E, we have DE, we have HE, and we have EF, of course, which is the line. So, so you have this one, this line, this line, okay, and then we look at point F. So we have CF, and we have GF. All right. So none of the other segments intersect EF. Okay. Next example asks us what planes are parallel to ABG. Well, if I look at ABG, we can see that's this bottom, the bottom of the cube. So it's pretty easy to see that really the only plane that intersects that is this top plane. Okay, so that would be plane D, E, F. or any combination of C, D, E, F. Okay, because this is C here. Okay, so any combination of the three of those, as long as you go, follow the lines around. So D, E, F, or um, E, F, C, or F, C, D, or C, D, E. Okay, or any of those backwards. So there's, but that's the top is the only plane that's parallel to the bottom. Next example is what planes intersect EFG. All right, so EFG is the back of the, so that's the back here. Okay, that's the back. All right, so what planes intersect those? Well, we have this the right hand side, which is G, F, C, this right hand side. You have the left hand side, which is DEH. You have the bottom, which is ABG. And you have the top, which is DEF. Right? So really the only plane that does not intersect it is the plane that's parallel to it, which is DAB, the front. Okay? That's the only one that does not intersect. All the other planes do. All right. So the next thing that we're going to look at is the interaction of three different lines. All right. So if you have two lines that are on a plane, and you have another line that cuts across both of those two lines, like in this case, this line right here. Okay, that line, or line T, is called a transversal. All right, and then you have the other two lines, line Q and line R, that are the ones that are being cut by the transversal. Divide that entire interaction up into both interior points and exterior points. So exterior is on the outside, sort of like, remember when we talked about angles, the interior was the inside of the angle between the two sides, and the exterior of the angle was on the outside of the two sides. So this is the same thing. This would be the same type of concept. So exterior is 1, 2, 7, and 8. Interior is 3, 4, 5, and 6. So that's what this key concept here is talking about. So pause the video and copy these notes into your notebook. Okay, so let's talk a little bit about how the angles interact with each other. You have consecutive interior angles. Well, we know they're interior angles, and we know they're consecutive. So consecutive means that they lie on the same side of the transversal. So in other words, 4 and 5 are consecutive angles, and 3 and 4 are consecutive, or I'm sorry, not 3 and 4, 3 and 6 are consecutive interior angles. All right? So So those are consecutive interior angles. You notice that thinking about 3 and 4 here, 3 and 4 are adjacent angles. Okay, 3 and 4 are adjacent angles that form 180 degrees. So 3 and 4 are supplementary. All right, 5 and 6 are supplementary. All right, so because they're adjacent angles that form 180 degrees. All right, the consecutive interior angles are, the reason they're called consecutive interior angles is because they lie on the same side of the transversal. Okay, so it's how they interact with this transversal T. Right, so pause this and copy this definition down right quick. All right, the next main concept that we're really looking at are alternate angles. So you have alternate interior angles and you have alternate exterior angles. And alternate basically means that they're on opposite sides of the transversal. So here, 4 is on the inside, is an interior angle, and it's on the left-hand side, and 6 is on the right-hand side. So 4 and 6 are alternate interior angles because they lie on opposite sides of the transversal. Along with that, 3 and 5 are alternate interior angles because they lie also on the interior, but they lie on opposite sides of the transversal. Alternate exterior angles, well, 1 is on the exterior and it's on the left. 7 is on the exterior and it's on the right. 2 is exterior on the right, on the top. 8 is on the exterior on the left, on the bottom. So those, you'll see that those are on opposite sides. The key part here, the key part of this whole thing is how they interact with, that wasn't a very good line, how they interact with this transversal that goes up through the two lines. Corresponding angles are angles that are basically, they take up the same relative space. So if I'm looking and I look at this right here, okay, and I can see that this line Q and the transversal T split that up. So this is top left, this is top right, this is bottom right, this is bottom left. All right. So, and then if I do the same thing with the bottom intersection, you have top left, top right, bottom left, and bottom right. So the corresponding angles are the angles that take up the same spaces. So top left goes with top left. All right, so we have top left right here, 1 goes with 5. So 1 and 5 are corresponding angles. 2 and 6 are corresponding angles because they're both top rights. All right, along the same lines, you have 4 and 8, bottom rights. I'm sorry, I labeled this wrong. This should be bottom right. This should be bottom left. Okay, so they're both bottom lefts, and 3 and 4, I'm sorry, 3 and 7, 3 and 7 are bottom rights. So those are all the corresponding angles. Pause this and copy this down. All right, So the rest of this lesson is just simply um, practicing these concepts we just learned. So what's the transversal that connects angles 4 and 10? Well, 4 and 10 is right there. The transversal is what goes across both of the lines. So this line is here, this line is here, and the line that goes across it is the transversal is G. So the transversal here is G. And what's the relationship? Well, you see that 4 and 10 are both on the interior. They're both interior. And they're on opposite sides of the transversal, so that means they're alternate interior angles. What's the transversal that connects angles 2 and 12? Well, once again, 2 and 12. So we're talking about the same intersections. 2 is there. I mean, 2 goes with this line, 12 goes with this line, and the transversal is actually the same transversal that we just used, which the transversal is G. And what's the relationship between 2 and 12? Well, you see there 2 and 12 are both on the exterior, and they are also both on the opposite sides of the transversal, so that would mean that they are alternate exterior. Okay? Transversal that connects angles 7 and 3. Angle 7 is right here. Angle 3 is right here. So here we're talking about these are the lines, and the transversal is the line that cuts across both of those. So the transversal is J. Transversal is J. Get the dot up above the J, not beside it. And what's the relationship between angle 7 and 3? Well, 7 is on the outside, is exterior. 3 is on the interior. That gives us a clue that they're not going to be either alternate interior or alternate exterior because we have one interior and one exterior. So they're either going to be corresponding or they're going to be consecutive interior. Well, it can't be consecutive interior because 7 is an exterior. So we check on whether they're corresponding. Well, 7 is top right, 3 is top right. So that means that their relationship is a corresponding relationship. And the last example that we're going to look at is what's the transversal that connects angles 13 and 10. Angle 13 is right here. Angle 10 is right here. Okay, so we're talking about this line and this line with the transversal that cuts across right there. So the transversal is K. And the relationship is that you see that they're both interior. So you know they're going to be something with interior. And we notice that they're both on the same side of the transversal. So they're both on the left side or the top side, depending how you look at it. They're both on the same side of the transversal, so they're not alternate. So that means they're consecutive. They're on the same side. All right. So make sure that you understand these primary concepts. The next lesson we're going to talk about is how those angles actually, how the measures of the angles interact with each other. Make sure you ask questions if you have something that you are confused about. We'll talk to you later. See ya.